Today we discuss about the different version of robots. Basically, it is the continuation of our history part, the history of robotics. Here, we differentiate the robot in different categories. Basically, it's to the version of robot. The version of the robot mainly but the performance is degraded initially due to the lack of research and interest in the field of robotics. The main cause of that, but after that, what happened? The industrial revolution happened, and the people observed that the robot easily solve the many problems which face in our real life, like which we already the shortage of labor, shortage of resources, shortage of skilled labor, resources, funds, everything. These are the main concern for robot evolution. So let's go that how we categorize the robot according to its performance and version. So personalization robot is simply pick and place. The first generation robot is simply pick and place device with no external sensor. Means, can you assume that a robot without any sensor, any feedback? So it is, according to me, it is nothing but a machine. So simple pick and place robot without any sensory feedback is the first generation of robot. So today in our laboratories we also integrate this type of manipulator with sensor. Now what are the sensors? You already know. The sensor is maybe ultrasonic sensor, infrared sensor, or proximity sensors. At least these type of sensors we integrate in our robot laboratories. So the first generation sensors, due to the lack, first generation of robot, due to the lack of sensory technology, the robots is not a intelligence robot, so it is basically a machine. In second generation of robot, the external sensors are integrated. External sensors like vision, tactile sensors. The tactile sensor is nothing but the sensors for touch are related. Like in our previous phone, the touch capacitance is the one kind of tactile sensors for interaction with the environment. So the interaction with the environment is necessary. That how a robot interact with its environment. Means some part of some sense of the robot that it interact with its environment in such a way that it gets some feedback from the environment. So feedback is necessary, and the feedback data are provided from the external sensor. The third generation robots are intelligent, smart materials along with this, and these are mainly the bio-inspired robots, micro robot, cyber robots. All are the third generation robots. So today we basically use the advance of third generation robots and also the fourth generation robot. In fourth generation robot, the intelligent algorithms are built with the development of software technology, development of microcontrollers. So intelligent robots are built. So the question is, what are the version of the robot? So if I say that the version of the robot is four types. Version 1, version 2 is, version 1 is the previous without sensors, then external sensors inbuilt, this is the version 2, and the third version 3 is intelligence robot, smart materials robot, and the fourth version is uh, a robot with AI. So these are the version of robot. So mainly version of the robot is 4. And today robots categorized in 4 categories. A robot with machine learning, robots with AI is nothing but all are included in version 4. Now, which one is the first industrial robot? The first industrial robot is Unimet. The first industrial robot is Unimet. In 1954, the first programmable robot is designed. Look at the first robot is mentioned in 19072, but the Unimet is the first industrial robot which is designed by George Devil, who coins the universal automation. So Unimet is nothing but the abbreviation, near to abbreviation is universal automation. And later they shortened these to Unimation, which became the name of the first robot company. So the first robot company is Unimation and the first robot is Unimet. Exactly. So if you go through the picture of Unimet, is nothing looked a simple robot. It is the one kind of automatic machine. If today someone told that this is a robot, maybe be funny. Better to say it is an automatic machine that used in industrial purpose. But with respect to the 1962, 1964, this is a robot. Okay. But if you compare this robot with our today robot, is quite different. The difference due to the advancement of mechanical system, electrical system, and the control technique. And now the another robot is Puma. The Puma is a famous robot. It built around 1978. The Puma is an abbreviation of Programmable Universal Machine for Assembly. So this is the one kind of real robot, Puma, programmable universal machine for assembly. So you remember this term, Puma, programmable universal machine for assembly. This robot is deployed by Unimation with a general motor design support. So if you look the Puma is basically there are 4 links. Link means if you consider our hand, this is the 1 link, 2 links, and the motor is fitted here. So it moves. So Puma is also like that. It is somehow the replica of our human hand. So, and also its link called the link one, hand two. And this robot is developed by the Unimotion for particularly assembly purpose. So in assembly purpose, our hand is the perfect hand, but somehow this robot is look like our hand, and all are the rotary joint. And the motors is developed by General Motors. But I saw this robot in IIT Kanpur, but unfortunately the production of this robot is stopped because due to its the limitation. One of the main limitation of this robot is payload. So I say the payload, it is an important term for a robot. So payload, okay, you have any idea about the payload? Any idea about the payload? Payload is the important term for robotics. Means how much weight it able to carry. Yeah, means how much load it able to carry. So what is the payload? The same thing, na? The weight robot arm can lift means how much weight it able to carry. The same thing. So payload is 5 kg means it able to carry 5 kilogram by its n effector. So the robot able to lift 5 kilogram. The weight carrying capacity of Puma is maximum 5 kilogram. So assume that it able to carry only the 5 kilogram, but that time this robot is one of the perfect robot for industrial automation, for basically the assembly purpose robot. So the first assembly purpose robot is Puma robot, and its maximum weight bearing capacity near about 5 kilogram, but the cost of the robot is very high, and it consists of 3 main links, one link for base, then second hand, and the third. So basically 3 links are there, and the main drawback of this robot is that the singularity is present in this robot. Means if when it is work in its boundary means if you stretch your hand, and this point it reach its boundary. So when the all three arms are stretched, then the singularity point is assigned, and due to the different solutions, and in our class we also discuss about the singularity point. Near about 1980, the robot industry developed faster. So from the Unimotion, Puma, the robots are appearing. Scara robot. Okay, Scara robot is the one kind of robots. The Puma is basically look like a human arm, whereas the Scara robot is the rapid growth, due to the rapid growth of industry for performing some specific tasks. The Scara robots are appeared. The Scara robot is a very high-speed robot that times, and it's easy to program. The other robots are another robots is the Scrum robot, Sevex 3 robot. All are the third generation of robots, and this robots is integrated with sensors. The sensors, Puma also integrated with sensors, but some limitation of sensor that time. And the latest Puma robots, now the Puma is stopped. They are not developed the Puma robot, but the latest model of the Puma robot, that is last, is integrated with the sensors, because they are developed the new kind of robots, which is the better with respect to the Puma robots. But the Puma robots have huge demand that time, because the program of the Puma robots is very easy and very simple. So the robot courses are spread across the mechanical engineering, electrical engineering, and the computer science that togetherly developed a new kind of the robots day by day. In 1995, the engineering application in the small robot and the mobile robots tried a second growth of startup of research. So people find the advantage of the robot, and day by day the cost of the robot is decreases gradually. And the last is after that the 2000 is the 2003 the NASA Mars robot, that is the robots is the totally unknown territorian, that the Mars robot is for the expedition of the Mars. In the same time, the underwater robot is also developed. Space robot, underwater robots, all are take place in research. So the journey started from 1954. 62 is the first Unimotion robot. Then 74 is the Puma, and 18-year-old the Scara robots. The year is not mentioned correctly because these are all under research. Okay. So near about. So 2003, the NASA start the Mars robot or expedition, and the result is very good. It's unexpected. So today all we call that robot built in our laboratory. Okay. The applications of the robot is the traditional robots are applied anywhere. One of the three exist in any job, like too dirty, dangerous, and or dull for a human to perform. So everywhere you able to apply the robots. In industry, rural robot are used for manufacturing, pick and place, assembly, welding, spray painting, etc. The remote operation of the robot is include the drones. So drones, nuclear environment, bomb disposal, law enforcement, and the outer space. And the service robot have been implemented as hospital, uh, handicapped persons, retail household servant. Okay. Now, the knowledge base for robotics, for robot design, these are the 6 major criteria for development of robot. So first is the dynamic system modeling and analysis, feedback control, sensor and signal conditioning, actuators and power electronics, hardware computer interfacing, and computer programming. So in our 3, we discuss about the modeling of the system. So the dynamic system modeling, we discuss about the static system modeling and the dynamic system modeling. The modeling is the one of the main part of robotics. So dynamic system modeling, then the feedback control also some point we discuss in class 3. Now the sensors and signal conditioning circuits, which purely belongs to E-engineering. Either you say the electronics or electrical engineering, because the electrical is the mother of electronics, so I have no argue of that. The actuators and the power electronics, then the hardware and computer interfacing. During this course, we also know that how we program the robot by using microcontroller as well as the computer programming. So this concludes the basic part of the robots. So the robots, the disciplines are everything. You have to knowledge in mathematics, physics, biology, mechanical, electrical, electronics, and the computer science. Okay. So thank you for morning session.